Hello. Good. Good afternoon, everybody. Welcome to the series of Informs tutorials this year. This is a tutorial in the area of MultiCriteria decision analysis and will be delivered by Gilberto Montibeller. He is the professor at the Department of Management Science at Loughborough University, and he's the head of the Management Science and Operations Group, which is a top research group in this area of research in Europe. Before he came to Loughborough, he spent 10 years as a member of the Decision Sciences Group in London at the London School of Economics and Political Sciences. He's an expert on MCDA, multi-criteria decision analysis, and he focuses specifically on behavioral aspects in this field. He has experience in decision analytic applications with emphasis in global health and strategic prioritizations. He's published widely in the field. He has served as the area editor for the Journal of MCDA. He's currently on the editorial boards of the Informs Decision Analysis Journal and the Euro Journal on Decision Processes. He's been recognized by awards. For Best Publication Awards, he was presented award from the Informs Decision Analysis Society, from the Society of Risk Analysis, and from the International Society of Multi-Criteria Decision Making. Gilberto, I'm inviting you to start your tutorial.
Okay. So thanks. Maybe you should switch this off. Thank you. So thanks, Margaret, for the presentation. Nice presentation. Thanks also to Douglas Shear for all your support in putting together. I know that it's always a struggle after lunch, but I hope this is not going to be too boring. Okay. The plan for today is, for this session is I'm going to give a brief introduction on the topic. I'm going to talk a little bit about facilitated multi-criteria decision analysis, how we can use multi-criteria decision analysis with groups. And then I'll go to the three main topics of this tutorial, which are how we can improve the quality of judgments of individuals and groups, both policymakers and experts. How we can better refine the interaction between models and users. And finally, how we can enhance interactions among members of a group, both policymakers and experts. And I conclude this talk by talking a little bit about threats and opportunities in this field. There are two things that I've taken two assumptions here in preparing this tutorial. The first one is that you might not know a lot about behavioral decision research. And for that reason, I'm using some puzzles and tasks here just to illustrate the points and also to make it a little bit more interactive. The second assumption here is that you might not know a lot about multi-criteria decision analysis. And for that reason, I'm starting showing one project and just showing the steps that we adopted. So basically, I think it brings everybody on board for this. The other thing also is I would rather prefer that this is a more informed, despite the lectern, I would rather prefer that this is a more informal talk. So if you have questions, instead of just waiting to the end, just feel free to raise questions or make a comment as we go. I guess we can have a microphone, right, Steve? If there are, no, if there are, I can repeat the questions if you want to have on record. Okay. So if you do not know the geography of England, Loughborough is right in the middle of the country. It's in the Midlands. It has probably the best beers in the country. If you like warm English ales, that is the place to be. It's 1 hour and 20 minutes from London by train. And we are very strong in sports. That's why we have this inspiring winner since 1909, because many of the British Olympic teams train in Loughborough. So there is some pressure for us to keep fit as well. You know, the lazy professors from the business school should also keep a bit fit. Probably you haven't heard about Loughborough because it's a big campus in a small town with, I suspect, the hardest word in English to speak because you have O-U-G-H twice and they have different sounds. So it's Loughborough. And as a non-native English speaker, I always struggle with it, but my 12-year son, he can speak very properly. He was born in England, so he can speak very correctly this. And the biggest city nearby is Nottingham, and I guess you heard about the sheriff, right? Okay, so that's where you are. Yeah. It's also very good, very strong in terms of engineering degrees, and particularly a focus in decision sciences in the business school. And that's why I decided to join them a few years ago. Okay, so we are focused here on problems of public policy. And as we know, anyone that has worked in any problem that is linked with public policy, we know that they are rife with conflicting objectives. There is, for instance, a conflict, usually a conflict between efficiency versus fairness. So if you are allocating resources in health, for instance, would you rather allocate resources for maternities or for dementia? If you do for the maternity, you are favoring children and young families. If you are spending more money on dementia, you are favoring an elderly population, and that's an issue of fairness. Yeah? There are many times technical criteria versus political goals. So for instance, if you are allocating projects within a given organization, would you, let's say that the most efficient ones is to allocate all the projects for a department, auditing projects, and the other departments then wouldn't have anything else to do, but that would create a lot of political conflicts inside the organization. So you might decide to actually spread a bit the auditing projects, and each department does a bit instead of just focusing on total technical criteria. And then there are, of course, issues of costs versus multiple benefits. And many of these benefits are difficult to monetize. What we're going to look at here is basically multi-criteria decision analysis. If you are not an expert on that, let me just tell you that these are robust methodologies because they are based on decision theory, how humans should make coherent decisions. They are based also on measurement theory, so how preferences should be measured and should be aggregated. And there is a lot of behavioral decision research that basically guides how we should elicit preference parameters and judgments from experts and particularly policymakers in this field. So they are very well designed or very suitable for supporting policymakers in making tough evidence-based choices. I emphasize here the word evidence-based because what we want here is not just to have judgments about priorities, but we also want to have the best evidence available to back up the choice of a given policy or a given option. And also they can help planners in designing better policy options. So it's not just about selecting options. I would rather say that in many decision problems, design is more important. The more strategic the problem, typically, the more important is designing against choice. If we take a look on historical perspective on why, you can ask me, so why are we using multi-criteria decision analysis for supporting policy making? I think you can look at a historical perspective and see that there are some trends here that basically took us where we are. The first one is that, particularly coming from starting in the US, a consolidation of cost-benefit analysis in the Reagan years. That basically was the first president that really pushed for regulations to be based on cost-benefit. Then there is a call for assessing or taking into account price-led impacts of benefits and costs that are very high. They are priceless because they are not because they cannot be traded, but they are very hard to monetize. And this really calls for methods that can take into account non-monetized things that cannot be easily monetized, benefits and costs. Then you have in the US with Kinney and Rife, and in France with Bernard Roy, These methods, these multi-criteria methods being developed, and if you see from the beginning, in both cases, they were focused on public policy. So Kinney and Rife, they have an application for the Mexico City airport. And Bernard Roy actually came from the public service and then became an academic. So the development of the electric methods, which is a kind of French school of multi-criteria analysis, or European school, if you wish, were heavily informed by his experience in how to deal with public servants and how difficult it was to get preferences from them. The other trend also that is, let's say, more traditional and perhaps even less academic is that these countries in Northern Europe traditionally had decision-making processes that were very participative. So if you go to Scandinavia, the Netherlands, you'd have a long tradition of, Switzerland, of people being involved in the local decisions. And this might explain why in Britain we had a set of methods that are facilitated operations research that were designed to encourage and support participative decision-making processes, including, in this case, the use of decision analysis by Larry Phillips from the London School of Economics. So this, yes. All right. Yeah.
Terminology, would you be able to explain any distinctions between decision analysis, multi-criteria decision models, MCDA? Sometimes people use those terms to mean something different.
Okay, that's a good question. So what is the distinction between decision analysis, multi-criteria decision analysis, and perhaps multi-attribute decision analysis? So decision analysis typically has been used traditionally to focus on decision-making under uncertainty. Yeah. I rather like to use as encompassing everything, which is decision-making under uncertainty, but also decision-making with conflicting objectives. So in decision-making with conflicting objectives, then you have multi-criteria decision analysis, which would encompass everything, and that is about discrete choices. So you'd have the analytic hierarchical methods, AHP, you'd have the electric methods from France, you'd have the multi-attribute utility methods from the US, and so forth. And then you have multi-criteria decision-making, which typically is used for decisions with continuous spaces, so it's the multi-criteria optimization. Yeah. I should say that the terminology is not very, coherent, so sometimes we have different names for similar things. And also in Europe and the States, you have a slightly different terminology. So it's a bit convoluted, the terminology. Yeah. Good question. So during this talk, I'm going to use as illustrations 5 projects that I've been involved in the past decade, most of them more recently, but I would say that the oldest one was 10 years ago. The first one was the evaluation of capability of health systems against rabies for the World Health Organization. Rabies is the deadliest virus in the world. So if you are bitten by a dog that has rabies, if you are not vaccinated in 48 hours, you are dead. So it's much more serious than Ebola and anything else. And it affects disproportionately old populations and children in poor countries. So having systems that are capable of dealing with rabies threats is a very important thing. The second project, which I'm going to detail more here, is the prioritization of low moisture food categories for the Food and Agriculture Organization of the United Nations, is FAO. And as I said before, I'm going to detail this a little bit more because I'm going to use as an example how these processes are built up. The third one is the assessment of biosecurity threats for the Department of Environment, Food and Rural Affairs. So that's the Department of Agriculture plus the Department of Environment together for DEFRA. And the idea here was to support the prioritization of resources for emerging biosecurity threats, such as, for instance, a new outbreak of a mad cow disease or outbreak of a camel flu and things like that. The next one is the evaluation of malaria treatment kits for the Malaria Consortium. That's the USAID and USAID. This was a project jointly with MIT, and we just presented this project here in the Decision Analysis Society Practice Award. I'm going to mention a bit later about this project, but basically it's about trying to find the bundles of these kits that better provides value for all the agents in the supply chain. And finally, the fifth project that I'm going to mention here is the prioritization of value for money auditing studies for the UK National Audit Office. So these are auditing studies to assess value for money, and they had to prioritize which projects to do every year. Okay, so that's it. So as I said before, what we use here in these projects is what we call facilitated multi-criteria analysis. So in this case, FAO asked our support to guide this group of policymakers in prioritizing how much impact overall each one of the low moisture food categories that they were dealing with would cause. So these are things like rice, dried proteins, spices, and as you can imagine, rice, for instance, is a very important type of food in the world. It maintains basically all Asia. Without rice, half of the human population wouldn't survive, basically. And what they wanted to know is overall which of these categories had the highest impact, so they can be further regulated in terms of risk regulations. And also trade rules could be improved. So the recommendation, eventual recommendation here was to select one low moisture food category to be let's say, prioritized. So we had here policymakers and experts from different countries. So we had a Japanese, which was an expert on rice. An American lady, she was an expert on almonds. We had one guy from Switzerland, Nestlé, on dried cocoa, and so forth. And UK, and so on. And the task here was in 2 days to develop with them a multi-criteria model and use this model to prioritize the low moisture food categories. So the way that these models work, if you use here multi-attribute utility, actually a multi-attribute value analysis. And the way that this works is you have an overall objective which is decomposed into sub-objectives and sub-sub-objectives. And at the bottom of the value tree, you build up an attribute that measures the achievements of this objective on this performance index, and a value function that tells you how much the marginal value, as the performance increases, how much the marginal value increases. In this specific project here, the attributes are linked with impact, so the higher, for example, the volume of trade, the more value it would bring to the category of food. The more the burden of disease, the more value it would bring to the impact, to the category. So you have value functions that map out and normalize all these impacts. You aggregate these partial values with the weights on the criteria, and you have an overall evaluation here. So this is, for example, one alternative B. It has a given level of trade, and then you have convert a normalized value of trade. You do this for all the attributes. That's another category of food. And then basically you use the weights to aggregate somehow and get an overall assessment, typically between 0 and 100. Okay? So these are the criteria that we used, that the expert decided during the workshop. So the overall impact was divided into 4 main aspects: international trade, burden of disease, vulnerabilities from food consumption, and vulnerabilities from food production. And then food consumption was further decomposed into average serving, proportion of vulnerable consumers, and so on and so forth. So you have a decomposition for each one of them. For each one of the bottom level, so you have the bottom level objectives here, we developed an attribute. So for instance, the attribute for impact on international trade is the export value in dollars, billions of dollars per year, straightforward. Yeah. In some case, vulnerability due to food consumption, for example, the average serving, the more you eat, the more vulnerable you are to this food. So the number of grams per day was the attribute for this. But in some cases, there was no natural attribute like this, and you had to build up indices, like for this one, proportion of vulnerable customers, like children, for example, are more vulnerable than adults if they eat a contaminated dried protein. So this was the proportion of food consumed by vulnerable groups, toddlers and elderly in particular, and so on. So we had an attribute for each one of them. Okay? In this case here, we used a simple weighted sum. So basically, you have the weights of each attribute at the WI, VI at the partial value. So what we had here, so this is the partial value. And XI are the performance of the alternatives. And these are, as I said before, normalized between 0 and 100. And we had a simple weighted sum to aggregate the partial performances and the evaluations. But for this, we need very strict preference conditions. We cannot just sum up if we wish to do so. And in particular, you need weak difference in the independence condition, which tells us that the value between two levels on a given attribute has to remain the same, whatever is the value of this food category on the other attributes. Yeah, so it's a ceteris paribus analysis. I'm not going to go into the details of any MCDA from now on, so I'm assuming that this is enough for us to think about the behavioral issues. But there is a big literature on how to build up these models. Okay? In this case, we use a linear function to assess the burden of disease. So we have the categories here, and we have the categories on the left. We have the DALIs, so this is basically the cost, the quality of life impacts of different outbreaks of salmonella and things like that affected those categories in the past. And this is normalized, so the highest total DALIs gets 100, and the lowest one gets 0. Yeah. But I should say that often these value functions are not linear. This one is linear because you're talking about lives, and every life is worth the same. But typically, you have non-linear value functions. And indeed, we know that these models are sensitive to the shape of the value functions. And then we have the overall value. So if you take those partial valuations, you multiply by the weights that we obtained. Category 1 was the one with the highest overall impact. And this is cereals and grains. Big volume of consumption and trades, and also relatively high burden of disease. Okay? Right. So how this was built up? This was built up with in a workshop in which 2 days, basically, we facilitated the policymakers in defining the objectives, defining attributes, listing value functions, listing weights, and at the end, collecting evidence to populate the model and come up with this overall score. Okay? What happens here is that in this case, we are basically working on 2 dimensions. We are working on a modeling space, which all of us are well aware of because we are operational researchers or management scientists. But also we are working here on a group space. And the group space is something that many of us are actually not so used to. Yeah? So you are playing a role of a facilitator and a decision analyst at the same time. In terms of facilitation, what you have good practices on how to facilitate groups. And basically, you are interacting with the group and making sure that the group dynamics are efficient and positive. But also you are modeling the problem. So basically, you are coming from multi-criteria decision analysis and using the modeling rules to create the model. So the group, basically, there's an interaction between group and model where the group provides information to the model and the model generates responses to the group. And there are 2 outcomes here. So one outcome are group outcomes. For example, you want the group to commit to action. You want the group to learn from their decision problem about their preferences, about their priorities. And also you have model outcomes, for example, the ranking of alternatives. But notice here that these 2 things interact. So if you have, for example, a group processes that are dysfunctional, this might have a negative impact on the quality of your model. On the other hand, if you have a model that is wrong, this can have a negative impact on the group interaction because people say, I don't trust this. I think this is really not how it should be done. So you have a strong interaction here between those 2 things. And while most of us are heavily focused on model outcomes, in terms of organizational change, I would say that group outcomes are probably even more important, because you want the group to actually implement the solutions that the model is telling them that is the best one. Now, so now we saw that in a very fast way how these models can be used in practice and what is the philosophy of facilitated decision modeling. And the question now is, so what are the things that we have to pay attention here in terms of behavior? So what are the behavioral aspects here that matter if you want to have successful implementations and interventions in this type of setting? And I'll say that we are confronted with the behavioral Bermuda Triangle here. Have you guys heard about the Bermuda Triangle? So the Bermuda Triangle is, was something that in the Bermuda, there is near the Bermuda Island, there is an area where many airplanes disappeared, especially after the Second World War. And there are many theories why this was happening from, we don't know, there are many, many theories. I mean, what we know now probably is that there are many hurricanes, and it's a very unstable, environmentally very unstable area, and that's why they had so many accidents. But basically, it's a place that sinks planes. And if you do not pay attention to the behavioral issues that I'm going to show now, from now on, I think you take the risk that your interventions might sink as well. Okay? So let's see what are the three things in the Bermuda Triangle that we have to pay attention to. There are group judgments, and I'll put here individual and group judgments as one of the legs, one of the aspects here. The second one is that there are user model interactions. And the third one is that there are group interactions, so how the group interacts by itself. And human behavior is in the middle of this. So basically, you cannot get a successful intervention if you do not pay attention to human behavior. And that's what we're going to see from now on. Okay? Let's start with group judgments, and I'll put here individual judgments and group judgments. So if you look at a multi-criteria model, there are 5 types of judgments that are required here. The first one is that you have to identify objectives. What are the objectives that are going to be used in this analysis? Then you have to define attributes for each one of the bottom level objectives. You have to elicit value or utility functions. Let me say here that value functions are used when you have riskless choices, and utility functions when you are deciding under uncertainty. Then you have to elicit weights, and you have to estimate impact. So there are judgments in each one of these stages. And what I'm going to do now is to look at each one of them and look at what are the biases that we might suffer and what kind of debiasing tools can be used for each one of these stages. But I'm going to ask you to do some things before we do that. Okay, so now let's start with before that. So if you are modeling individual and group judgments, there are 2 types of biases that can play a role here. One type of bias is cognitive. So your judgment might be fault because cognitively you are not, you are struggling to make the judgment, or you take a shortcut that leads you to the wrong way. Or it can be motivational as well, because somehow you favor an alternative, for instance, and then your thinking, your judgment is focused on making that alternative win because you really like it. Yeah? So these are the 2 types of biases. In these bias judgments, because the inputs in our models are typically preferences and judgments, this can have a negative impact on the quality of our models. And there are debiasing tools available for each modeling step. So I'm going to use heavily here a paper that was von Winterfeld and I wrote a few years ago, 3 years ago, in which we revise this very extensive literature and check all the biases and debiasing tools and all the evidence that they exist. So if you say, okay, bias is something that really I'm concerned with because I know that they affect my judgments or the policymakers' judgments. So where should I look now? Well, I think what you have here is what I call a bias safari. If you look at on Wikipedia, there are hundreds of biases that have been discovered. And indeed, psychologists now are trying to hunt a new bias so they can make their careers out of it. But for us, this is complicated because basically then we are really stuck. We know that they matter, but there are so many. What should we do? And then what Detolf and I did was we think that we identified a small subset of biases that matter in our context, in decision analysis. Because many of these biases actually are for unsupported decision making, which do not apply really here. Okay? So I'm just focusing on biases that matter in our context. So let's focus now on identifying objectives, the first task in any MCDA application. And now I need you to think a little bit about this. Okay, so imagine the following. Imagine that you are considering a new research project. If you are a researcher, let's say that you are, now I want to do a new project. If you are a master's student, that, I have to decide for a PhD topic. So basically you are deciding for a new research project. Think about and write down all the objectives that matter to you in selecting the topic of this new research project. So you have to get a piece of paper, please, and write down everything, all the objectives that you'd have in selecting a new research project. The more, the better. I'm going to give you a few minutes for that. So write down all the objectives that matter in selecting a good topic for a new research project. Let's see who gets the biggest number of. You can list, no, you just have to list them. You don't have to organize as a value tree. So the question if you need to have sub-objectives, is just list them as a list. Really, please. Let's see who is there. I should have brought some warm beer from England so I could give as a prize. Yeah. Okay. Finished? Sort of. Okay, so now let's do the following. Second task. Select from this list all the objectives that matter in this decision, please. So let's see, how many you had initially and now, please?
I had 6 and now I have twice that many.
6 and now 12. And you here, please, in the front?
4 and then 8.
4 and 4, from 4 to 8. Michael?
I had 9.
9?
Now I'm at
9, 18. You, please?
3 and unlimited, I can't.
3 and 31. 10 times. Yes, you, please?
2 and 2.
2 and 2, so it remains. And you on the left, please?
5 and 4.
5 and 4, so it remains. Margaret?
I went from 6 to 10.
6 to 10. Doug?
I went from 7 to 9.
7 to 9. You here, please?
5 to 10.
5 to 10. 3 to 4. 5 to 8. Yes. 8 to 12. 7 to 10.
9 to 17.
9 to 17. Yeah. The finding, I mean, this is if you think about it, this is a pretty important decision for most of us, right? Because we might spend several years doing this project afterwards. So it's not a trivial decision. And the finding that we have here is more or less, it was very squeezed in terms of time, but the finding is that with more controlled experiments is that basically we list half of the objectives that matter. And that is a big worry, because if you think about it, if you are not listing the objectives, you might be missing actually important issues that you want to take into account later on. So that is a worry. And this is called the omitted variable bias. And this bias happens also for alternatives, so you might have an alternative that is missing, and for uncertainties as well. Yeah? What are the other biases? So one of them is omitted variable bias. What are the other biases that might affect the definition of objectives? One is availability bias, so you think about just a limited amount of things. And the other one is you might have a problem representation that is myopic, very narrow, and again, you might miss important objectives. So what can we do to improve the definition of objectives? What are the debiasing tools? Well, you can provide categories. So the one that I had initially was a wish list, right? But I could say, can you think about a project that went particularly badly? What were the attributes, the features of that project? Or can you think about a project that went very well? Again, what were the characteristics of that project? So there are many categories that can be used. Prompting people to generate more objectives and stimulating creativity, so think creatively about it. And also you can employ more sophisticated problem structuring methods to support the definition of objectives. So for the FAO project I mentioned before, we used a causal map that basically maps the causes and the ends in this problem. And with this, we identified the objectives, the 4 criteria that we use in the model. So for instance, they say, know what are the control measures leads to know the way the food is consumed, which leads to produce safe food, which leads to facilitate the international trade, which improves the country's economy. So basically, there is a group of issues here that were linked with the vulnerability to food consumption, and a group that were linked with the vulnerability of food production and burden of disease in international trade. So again, these maps are built up interactively and very powerful in making people think about these means and ends and how they can be achieved, and very good for identifying objectives. Yes?
So when you said that one of the biases being that decision makers, individuals only choose about half of the objectives, to what degree does that apply to groups? And my question is, have you seen any research about measures of diversity of a group making decision versus the presence of biases?
Yeah, I am not aware about any research that would explore exactly this issue in groups. I mean, there are biases which I'm going to cover later on in groups that would tell us indirectly that lack of diversity would impact negatively on the creation of objectives. But I'm not aware about a specific research project looked at the impact of groups in generating objectives. Yeah, that's a good question. Yeah. But my guess is that the lack of diversity affects negatively, and further diversity, more diversity, probably would increase positively, given what we know about group judgments. Very good question. The second one is the definition of attributes. So once we have the objectives, we have to define attributes, performance indices to measure how much the options are achieving what we want to measure, or what we want to achieve. So let me ask you the following situation. Okay, the previous government in Britain, the Labour government, in 1998 set up as one objective, fundamental objective, was to minimize child poverty. And if you look at the index of child poverty in 1998, it was 26%. So you look at families that are poor, if they have children, then they are classified as children under poverty, which is rather shocking for a rich country as Britain, I should say. And this is the measurement of absolute low income. So 60% of the 1998-99 median in real terms. So basically you fix the income in 1998, 1999, and you see how much this index is changing. And as you can see here, it has fallen from 26 to 11 in 10 years' time. Yeah? So are we achieving this fundamental, was the British government achieving this fundamental objective? It seems so, right? I mean, it's not zero, but it has been reduced. Now let's look at an alternative way of measuring this concern, which is the relative low income. So every year you calculate the median, and you take 60% of the median, you see how many families with children are under poverty levels. And this is what it gives you. Yeah? So actually there was no much decrease. And guess what happened here? What was the reason for this decline here? Any guess? It was the Great Recession. So the Great Recession affected everybody, but the really poor were slightly more protected than the rest. So basically everybody became poorer, but the poor were not, they stayed where they were. Yeah? So what this shows actually that there was no improvement whatsoever, and all the programs for children benefit, for improving child poverty actually, maybe were not so successful. What's the point here? Well, the point is that the attribute has to measure more directly the concern that the government has, or the policymakers have. Are you concerned about absolute poverty or relative poverty? And this calls for different indices and different targets and different actions. Yeah? So measuring directly the achievement of a fundamental objective in policymaking is very important. Yeah? What are the biases that we have in definition of attributes? We have gain-loss bias. I'm going to talk about this a little bit later on. There is a proxy bias, so we know that attributes that are more indirect are typically receive more weight, and also the measurement sometimes is not so good. And also there are scaling biases, so the way that you define the scale might have a negative impact on how the preferences are identified later on. Debiasing, well, try to use natural scales as much as possible, and be careful in selecting the endpoints of your attributes, because they really matter for weighting as well. The next step is eliciting value and utility functions. And as I mentioned before, value is for riskless choices, and utility is for decisions under uncertainty. In utilities, typically you have judgments that involve prospects, and evaluation you don't. Yeah? So now let's see. I don't know how many of you know this. This one is a well-known case, but let's hope you don't know. So imagine that the US is preparing for the outbreak of an unusual camel flu disease, which actually is happening. So I suggest you to be away from camels, because in the Middle East they are transmitting they might transmit camel flu, which is expected to kill 600 people once it reaches America. Okay? Two alternative programs have been proposed. So now we have to divide here. Let me call this group 1 and group 2. Okay? So you guys are group 1 on the left, and right side group 2. So group 1, please close your eyes and keep them closed. Okay? Group 2, you have to read it. I cannot read for you. And decide which one. Decide which policy you prefer, please, and write down. Just keep in mind. Okay? Choice made? Right. Now, group 1, open your eyes, please. Thank you. Group 2, now please close your eyes. okay? And you guys have to identify which policy, in group 1, which policy you prefer. Just select one of them, please. Okay? So now everybody can open your eyes. Okay, the first one, have you selected A or B? A. Most people selected A, right? The second group, have you selected C or D? D. Most groups select D. If you look at the expected value of these two policies, they are the same, right? Because you have 200 people here, and here you have 600 multiplied by, let me see, 2/3 probability. Yeah, so basically if you multiply 1/3 by this, it's 200. So the expected utility is the same, expected value. Exactly. Exactly. Again, here, if you see this, they have the same expected value because it's 1/3 probability that nobody will die and 2/3 that they will die. But because of the die or survive, we change our preferences. So most people prefer A. So we are risk averse for gains, but we are risk seeking for losses. And this is the famous, I don't know if you heard about the famous prospect theory of Kahneman and Tversky that shows that basically you have different risk attitudes for a consequence if it's on the gain side or on the losses side, and the reference point really matters. In our paper, we call this the gain-loss bias. So depending if you see as a gain or a loss, you might have different valuations about it. Yeah? So what are the biases that we have, all the biases that we have in utility and value elicitation? Well, the gain-loss bias is here. It's cognitive. We have the certainty effect bias, so people prefer something that is for sure than something that has an uncertainty, even if the thing for sure sometimes is not the best one in terms of expected value. We have an anchoring bias, which I'm going to mention later on. But we also have motivated biases. For example, we have biases which affect. So if you have an environmentalist, they might overvalue if you have an environmentalist assessing a new nuclear power plant, they might overestimate the costs and underestimate the benefits because they are against nuclear energy. And if you have a nuclear engineer, it might be the opposite. They might underestimate the costs and overestimate the benefits. So that's a motivational bias. And again, desirability of options is the same. So you might have an option that you really like, and then you push the value functions to favor that particular option. Yeah. What are the debiasing tools available here? One thing is to separate value and utility when you list them. You separate also gains and losses, and you might use group procedures with diverse policymakers to try to reduce those biases, particularly motivational biases. Let me show you this case here. It was an interesting case because this is the one I mentioned before about assessing the capability of health systems against rabies. And this system was developed for two things. If you have more resources, which capabilities should you invest on? So which capabilities are the most valuable ones? But the other thing that we also have here, which actually is a more common case, is if you have less resources, where should we cut, which is less painful? So which capabilities should be preserved and which capabilities should be cut? And we elicit twice the value functions for this problem. One for capability gains, which is the green line here. So if the capability increases, that's the value function of our experts. If, on the other hand, the capability is high and starts decreasing, so if you lose capability, then you have the orange function here. And indeed, in the decision support system that we developed, the two functions switch, whether if you are actually having more money, more resources to invest, or if you are cutting the budget. So basically, we used to our advantage here the gain-loss bias to develop the decision support system. Okay, elicit weights. So that's the other step. I would say this is probably the trickiest part of any MCDA assessment. And again, I'm going to ask you to think about this, okay? So let's imagine the following situation. Okay? You are considering different job opportunities, either promotions in your company or different jobs outside. Okay? Assume that you have only two objectives, nothing else. You don't care about anything else. You just care about salary and work-life balance. That's the only thing, okay? Now, if you can write down this, please, as task A. So we need a table now. So task A, there are two objectives, salary and work-life balance. Now, what I want you is to identify which objective is the most important for you among those two. And then you give a weight based on this importance. Of course, the most important one has to have a bigger weight than the least important one, and the two weights should sum up as 100%. So give a weight to the most important one and a weight to the least important one, so they sum up 100%. And have a table, please, where you have task A, weight for salary, and weight for work-life balance. So that's task A. Yeah. Okay? Everybody? Right. Now let's use a well-studied protocol for the elicitation of these weights. Okay? This is called, we're going to use the swing weights method. So let's go step by step with this. The first thing is, I'm going to define now very precisely those two objectives by identifying attributes. So the first attribute is salary per year, gross, in thousands of dollars. And the range that you have here, among all the options that you are considering, job offers, is between $120,000 and $100,000 per year. Okay? The work-life balance, the attribute is the number of average work hours per week that your job is going to require. And the range here, among all the options that you have, are between 40 hours per week and 80 hours per week. Okay? Now, what I'm going to do here is to identify the weights, but using an indirect procedure called the swing weights method. Let me show you what it means. Okay. Let's think carefully about this. So imagine the following situation. You are making $100K per year and working 80 hours. You have two options here. You can stay at 80K. You can stay at 80 hours, but move from 100K to 120. So you have this, but stay here. Or you stay at 100K, but you move from 80 hours to 40 hours. Okay? So either you move here or you move back. This is called a swing. So let's think about it again. So if you are here, and let's imagine, I'm going to give you several scenarios here. Let's imagine that you say, actually, I would rather prefer to move from 100 to 120K instead of and stay at 80 hours. If that's the case, this swing is worth 100. So let's fix this swing as 100. Okay? And the question now is, if this swing here is 100, how much is that swing there? Let's say you say it's half of it, 50. If that's the case, then you have 100 here, 50 there. Now you can just normalize those values. So you divide the 100 by the sum of the two swings, which is 100 plus 50, 150. You have 60% on this of weight here. This one is 50 divided by 150. You have 33% there. The other way around. So imagine someone else, and she says, actually, they say, actually, I would stay as 100K, but I'll move from 80 hours to 40 hours. So the first swing here is on the right. Give 100 as reference. So if this swing here is 100, how much is worth this swing? And they say 50. Now let's calculate the normalized weight. So this is going to be 100 divided by 150, which is 100 plus 50, 66%. And this is going to be 50 divided by 150, which is 33%. Let's imagine that someone says is the same. If it's the same, then this is 100, that's 100. The weights here would be 100 divided by 200, 50% each. Yeah? If someone says, oh, there is one swing that is worth 0, then it will be 100 divided by 0. That will be 100 divided by 100. That's 100% here and 0% there. Yeah, is it clear, this? Yes.
Do you have the opportunity to work overtime? Take a 40-hour job?
There is, let's fix this.
40 hours max.
Let's fix this, yeah. Let's fix the, let's simplify the things, yeah. So the thing is, which one would you move first? To the one that you move first, you give 100. And the second one, you give a score which is relative to the 100. Now you divide each one of the swings by the sum of the swings, you have the weights. So can you do this for this problem with those ranges, please? Okay? Everybody did it? Who got a heavier weight on work-life balance? Raise your hand, please. Who got a heavier weight on work-life balance? Yeah, okay, good. So we are on track. Right, so now let's imagine that you have a new job offer that was thrown into your option set. And now the range is not from 100 to 120, but it's from 100 to 200K. So can you do the same thing again, please? So you identify the first swing. The first swing gets 100, the second a proportion of these 100, and then you divide each swing by the sum of swings to get the normalized weight. The same as before. The only difference now is that this range now is wider. Okay? So who now got the salary as the heaviest weight one? Who got the salary? Who got the work-life balance? Okay. Right, so now another option was thrown into your option set, and the range actually is 300, not 200 anymore, the top of the range. So can you again do the swing weighting and the normalized weights for this range? To identify the first swing gets 100, the second swing gets a proportion, you divide each swing by the sum of swings, you get a normalized weight. Yes.
It's really personal.
It's really personal. There is no right. You cannot ask Alexa to give you this answer. Yeah? Because basically it depends on the.
How much your kids are.
It's a value judgment, right?
You
Yeah.
have kids.
Indeed.
And how much you like your work.
Indeed.
Is it your passion?
Yes. How much you like the money?
And how much it's so personal.
Yeah, yeah. And that's why people have different careers too, career choices. Yeah.
There's nothing you can do.
How nice a vacation you can buy with a 300.
Yeah, how nice a vacation. If you survive the 80 hours, yes.
Have a vacation.
It will be small, but it'll be very nice.
I want to hear your solution for this.
Yeah. Okay, done? Right, so what if you look at the 4 tasks that we got, The first one I ask which one is more important, yeah? And then I specified very precisely the attributes and the ranges, and I ask you to do a swing weight elicitation out of it. Yeah. My guess is that the weight on salary increased from the second task to the fourth task, right, everybody? It increased. Okay? Now, if you compare your answers with the first one, my guess is that they were very different than the first one. Because the first one is actually a question that shouldn't be asked. I shouldn't have asked you, actually. It's a meaningless question that can take you to really meaningful results. And there is behavioral evidence for that. Yeah? Because we do not know what people are taking into account when they answer for this question. And therefore, it can mislead the prioritization of objectives. Okay, so, point is that weights have to always be identified given the ranges of the attributes. And we see why this happens with this example, right? Because it depends on the ranges of the attributes. But we typically suffer from one bias, which is the range insensitivity bias. So we are not sensitive enough to the ranges. And this might lead us to problems in weighting. Okay? So what are the biases that we have in weighting? Well, one of them I mentioned here, the range insensitivity bias. If it's a proxy attribute, then typically it gets overweighted. The gains-loss bias also can drive the weights in different ways if it's seen as a gain or a loss. The equalizing bias is a push for people to give the same weights to everything. I care about everything, so I'm going to put the weights, all the weights. And I experienced this in one of the projects that I mentioned, where they wanted to have the same weights. Even with us enlisting swing weights and showing that was not the case, actually. But eventually they said, we have to have the same weights because politically we have to make sure that we care about the four impacts in the same way. The splitting bias, if you have an unbalanced value tree, the area of the tree where you have more decomposition typically would get more weight. So you have to have always a balanced tree to avoid the splitting bias. And again, desirability biases and affect influence bias, motivational biases can drive you to weight something, overweight something, or underweight something. Overweight something that you really like, and underweight something that you really like. But I think the point that she made is very important. There is no right answer for these questions. These are value trade-offs that have to be answered by the priorities that someone has about their lives. The biasing tools. You can use group elicitation, diverse groups. Avoid the use of direct importance. So the question that I ask you first, never ask your clients about it. And you can cross-check weights with the trade-off method that basically you check if the trade-offs make sense and pricing out. So there are methods where you can double-check these answers and avoid using proxy attributes. Okay? So with this, we finished all the value part of it. And before that, in this project, basically here we are prioritizing, again, the low moisture food. So that's a project for FAO. And we had to elicit the swing weights. But we could not ask them, would you rather cause more impact here or more impact there? They would see this as kind of, not acceptable. So what we did was we created 4 categories that were hypothetical, and we said, can you order them and then score them? So this category here, for instance, has a low impact on all the 3 sub-criteria. This is for the vulnerability from food consumption. This one has a high impact for the 3rd sub-criterion, mishandling, and the lowest impact for those 2. This one has a highest impact for food vulnerability and low there, and this one has for serving. Indeed, what we're doing here is like the swing weighting, but indirectly, because this was more natural for them. And we said, can you rank those impacts and then score the highest one as 100 and the other ones as a proportion of 100. So that was a way of getting the weights, making them think about the ranges, but in a way that was more natural, just about prioritizing categories instead of moving here or moving there. Yeah.
How successful were the practitioners in using the scheme you presented to them?
I think there was, in general, this group was very open to this kind of model evaluation. There was one lady that specialized in almonds. I think she felt uncomfortable in giving preferences because she was a hard scientist, and she thought that value judgment shouldn't go to science. And that's something that is common when you have scientists involved, is that they struggle to give you valuations because they think that that's not part of their job. Good question. Finally, estimating impact. So we go to the last bit here. If you have good predictive models, you should use them, of course. Yeah? If you have good predictive models, you should use the quantitative models. But often in complex policies, you do not have them, and you have to ask experts. Okay? And so that's what I'm going to focus on here. If you have to ask experts for estimates, what do you have to take into account? Right. Now I need you to turn off your mobiles because I'm going to ask it some general knowledge here. And if you have the mobile on, then you have a competitive advantage. Okay? Right. So this is the annual GDP growth of the United Arab Emirates from 1976 up to 1988. Okay? So in 1976, it was 16.5% the growth. In 1977, 21.4, and then it fell to minus 1.6, 20.9, 23.9, and so on. Okay, so that's the data from the country. What I want you is to estimate the annual GDP growth for the country for each year from 1987 to 1996, providing a minimum and a maximum value so you are 90% sure that the true value is within this range. So for instance, here, in 1986, we had minus 15%. If you think that the next year is going to be quite low, you could say, let's say, it's between minus 10 and minus 20. That would be your range. So what you have to specify now is for every year, a lower and an upper value, so you are 90% sure that the true value that really happened is within the range that you provided. Could you please write it down? Yes?
How could we know that's impossible?
Well, you have to use the knowledge that you have about the world and the country as much as possible. You have the past data. I mean, that's, if you think about it, we are dealing with this for all the variables in the world. I mean, what is going to be the oil price next year? We don't know, right? I mean, if you are in 1986, we have the past information. There is no data about the future. Okay?
But they would be able to get more data. We're not allowed.
Yeah. You are not experts. I guess you are not experts on the United Arab Emirates economy. So you have to take this into account in your estimates. Give it a go, please. Yes.
All those years. Individual for each of those years.
Yeah, for every year, yes, please. For every year. Oh, you know that their economy is heavily based on oil. That's a tip. A lower bound and an upper bound for every year. So you are 90% sure that the true value is within those bounds. Okay? Everybody? Finished? Right, so let's see if you got it right. So if you can just tick and see if you, how many you got right. Ready? So 1987, 3.4. So if you got within the range, the true value falls within your range, you got it right. Who got it right? Okay, good. Minus 2.6 in 1988.
So it just has to be in your range.
Exactly, just has to be within your range.
Okay.
Good. 1989, 12.3. Good. 1990, 18.3. Good. 1991, 0.9. Okay. 1992, 3.3. 1993, 1.3. 1994, 6.9. 1995, 6.7. In 1996, 5.8. Okay, who got 10 right? Well, that's not what I asked. Think about it. Given the task, how many should have you gotten right?
Gilberto, I got it right each time because my interval
Yeah, I
was
made it
huge.
huge.
Exactly. If you give a too big interval, if you put between minus infinity and plus infinity, you always would get right. But there is no information whatsoever about it. Yeah. So how many should have gotten right? 9, because I asked for a 90% confidence, right? So 9, anyone has got 9?
Doesn't 90% confidence imply at least 90%?
Uh,
I thought the definition of a confidence interval was at least 90%.
no. So anyone got 9? No? 8? Everybody got 10? Who got 8? 7? 4? 5? Yeah. The lower it is, the more overconfident you are. So basically, if you got 10, you are underconfident. That's not good because basically you are not bringing any information. I know it was a bit squeezed in terms of time. But typically what happens here is that people would give very narrow ranges and would miss many of the true values. And this is overconfidence. That's a very important bias for estimates. We tend to give ranges that are too narrow for our lack of knowledge. But I guess in this group here, actually the opposite happened. You gave very, very wide ranges because you didn't know anything about it, which is okay. Right. Now
One other thing.
yeah.
Is that what I did is I figured out when the U.S. elections were, and I figured that would drive up revenues. Uncertainty and various other things could drive up prices of oil and other
Yeah,
things in
yeah.
the Middle East. So therefore I had a positive. I was always positive.
Right. Yeah, and they were pretty, almost them were positive actually. It was a period of high prices.
90 was really high.
Yeah.
90 was really high.
Yeah, yeah.
But 86 was really bad.
Yeah. Who got, let me ask you another thing here. What is your prediction for 1987 for those who are not too optimistic? Was low? Very low, right? Very low. Yeah? Very low.
Lower than minus 15.
Exactly. Even lower. Yeah. So what happens is that this is due to anchoring. So anchoring is another bias that we are basically anchoring our estimate of the next year, which is 3.4.
If you look at the history, it usually it went up after.
Indeed, yeah. So anyone that got a low range for the next year here is because you're suffering from anchoring. Another important bias that really sticks. Okay. Anyhow, so what are the biases that we have here? So anchoring, I mentioned, overconfidence, and the other ones that I mentioned before also play a role. How can we improve this? We can use, if you have models and data, please use it. Yeah. You should be aware about these anchors. Try to avoid being anchored on things that do not matter. You can use counterfactors and hypothetical gambles. So you can say, can you think about a scenario where it's actually lower than what I thought, or that is actually higher than what I thought? And one research that we've been doing recently calls for automatic rules. So if you have very narrow ranges, you just say multiply 2 by 2 and divide by 2, and this reduces the overconfidence. Okay? Right.
So one question for you
Yes.
on that. You mentioned earlier issues about relative versus absolute measures.
Mm.
Are people better at estimating on absolutes?
Well, Guggenheiser has made some arguments about this, that the way that you ask for proportions instead of probabilities, for example, would improve judgments about probability. So instead of asking the probability that Donald Trump is going to be re-elected, you say out of 100 times that there is an election, how many times he would be elected? And the latter actually improves the judgments compared with the former. So there is some research about the format of this question that can have a positive impact on accuracy. Yes. Okay, so let me just conclude this part saying that all these are constructed judgments. We do not have these preferences and estimates in our minds a priori. So this is not we are not archaeologists of preferences in this field. We are really architects. So we are designing value models and making people think about it. But the way that you ask actually has an influence on how they are answering. Okay? So you have an elicitation protocol. You elicit judgments from your policy expert or policy maker. There is a cognitive processing behind this. She makes a judgment. You represent the judgment, in this case a cumulative distribution function, for instance, and revise the judgment. So what we want here is to use first adequate elicitation protocols. If you are eliciting weights, you should ask properly, not how important it is. Then you also want to use requisite modeling. So you want a model that is good enough for what is needed, but maybe not perfect. And you want to use debiasing tools. So these things together can improve the quality of judgments, but all these judgments are really constructed. I realize you have 5 minutes, so I'm going to just skip this very quickly and just say there is another 2 areas that are actually less studied than the first one. One is user model interactions, and the other one are group interactions. So I'm going to skip this. We know that there are cognitive limitations in providing judgments. If you look at the multi-attribute utility theory, they require either strict preference or indifference relations. So they are very strict in terms of the information that has to be provided. All the elicitation of value, utility, and weights are all cognitively complex. So it's not easy to provide those judgments. And then there is also cognitive limitations in you provide results and how people interpret results. Typically, if your policymakers have a limited quants analytical training. So how can you deal with that? Well, we have methods in Europe, I think there is a lot of development on this front, I should say. There are methods for incomplete preference information. There are methods with extended preference relations, the French methods, the electric methods, for instance. And there are simplified elicitation protocols for value assessment, like Macbeth, rank order correlations for weights, and so forth. The main trade-off here is between accuracy and effort. Yeah? In terms of cognitive limitations, in terms of interpreting results, what we advise is to use visual interactive modeling. So you play with the model and people see weights moving up and down and what happens with the results. Yeah? I'm going to skip this, we don't have really time. And I'm going to go to the last bit, the group interactions. There are many advantages of working with groups. Enhancing information, the pooling of information. Groups can help in checking errors. People can be more motivated if they work in groups, and they can be more satisfied. And also, if they work in a group, they typically are more committed to the way forward. So if they are involved in a decision, they can be more involved in, let's implement it. If that's the solution, let's implement it. The challenge in working with groups is basically groups have dysfunctional behaviors often, like an authoritarian leader, for instance. You can have members that want to just conform to what the group thinks. They might miss new information because the group is so cohesive. And they can represent the problem in a very simplistic way. Yeah. And also there are motivational losses. So anyone that's engaged in a committee in the university knows what I mean here. Yeah? And group coordination losses. So there are lots of coordination efforts if you work in a group. The other thing also that I mentioned before into your question is that there are group judgment biases. So all the biases that we've seen before were biased at an individual level. But there are also group bias levels. For instance, there is kind of the group can have a false consensus. There is groupthink, so the group is very cohesive. There is no information that can reach the group, and everybody has to think in the same way. There is group polarization, so if each member has a position, as a group they are more extreme. They can escalate to commitment, so again, if every member has some commitment to do something, as a group they are overcommitted. And the group can be overconfident, so if you have narrow ranges individually, they can be even narrower as a group. Okay? What can you do to debias group judgments? Employ multiple experts with alternative point of view, different perspectives. You can have listed protocols that are structured to avoid these kind of negative influences, and facilitate decision analysis. You also can redesign organizational decision processes, so you improve the processes, being aware about those dysfunctionalities. And I'm going to skip these examples here, which are about redesigning processes, really. Right, so let's conclude with this. So basically, how can you deal with the behavioral Bermuda triangle? You can use debiasing tools against to improve group judgments. You can use simplified elicitation protocols in iterative modeling to deal with the user model interaction. And you can use group facilitation and redesign decision process to deal with group issues. Okay. So let me conclude now. I guess we have 1 minute. Human behavior plays a major role in policy analysis with facilitated MCDA. So if you are serious about this, you really have to know a little bit about behavioral research. Experts might be biased in their estimates, individuals might be unable to express clearly their preferences, and groups might present dysfunctional dynamics. Okay. So we focus how to better manage behavioral issues, minimize behavioral biases from individuals and groups, and optimize the quality of human judgments in this model. So that's basically what the tutorial is about. And there are many opportunities in these fields. For example, there is very little on efficiency of debiasing tools. That's something I'm engaged now in terms of research. There is a relatively little on cognitive complexity of elicitation protocols, and on the effectiveness of visual interactive modeling. And also bias in facilitated decision modeling is something that hasn't been really explored that much. Oh, okay, I conclude now with 2 worries and 2 positive things, okay? 2 worries. My first worry is that I think we spend too much effort with technical issues in MCDA, and we assume that the judgments there are debiased and reliable. Yeah? So we spend a huge amount of effort in modeling and optimizing and stuff, but we assume that the inputs are debiased and reliable. They are not. They are not. In practice, they are not. Second worry. We assume that the decision maker is a single unit, is the decision maker that has stable, unique, and clear preferences. They are not. These preferences are not so stable, they are not so unique, and they are not so clear in practice. So, 2 encouragements now. First one is, I think we have to have our hands dirty on preferences, yeah, and group dynamics. So we want to debias preferences and more effectively facilitate groups. I think that is an aim that we all should take. I think this is going to help us in becoming better practitioners, but also it opens up avenues for research, interdisciplinary research, particularly between sociology, psychology, and analytics, decision analysis, management science. If you want to know more about this, there is a tutorial that has been written. I've heard that there are some free books available.
Not free.
Available books. Available. And there are 139 references there, so there is a lot of content that I haven't really covered in detail here, but if you are interested, that is, I think, a good source. And that's my address. And thank you very much.